Multiplying exponents. The most important thing you need to understand is that in order to multiply exponents, the bases must be the same. Let's start off with multiplying exponents using the expanded form. If we take the expanded form, we see that x squared is really equal to x times x, and x to the fourth is equal to x times x times x times x. So this is x squared times x to the fourth. So if we count up the number of x's, we have 1, 2, 3, 4, 5, 6. So we can determine that x squared times x to the fourth equals x to the sixth power. And again, most importantly, you can only multiply exponents that have the same bases. In this example, both of these terms have bases of x. So we just learned that we can multiply using the expanded form, but isn't there an easier way? There's another way to multiply exponents. Instead of using the expanded form, we can use the rule. And the rule says if the bases are the same, we can add the exponents. So let's say we have an exponent multiplication problem that looks like this. 5 to the second power times 5 to the third power. Well, first of all, we can see that we have two bases that are the same. Both bases are 5. So we don't multiply these bases, we just keep the base the same and we add the two exponents. So we get 5 to the 2 plus third power, which simplifies to 5 to the fifth power. Again, very important concept. We do not multiply the bases. If the bases are the same, we simply take the base as the answer and add the exponents. We don't change anything with the base, we just add the exponents. Let's try some more examples of multiplication using the rules. 3 to the fourth power times 3 to the second power. Both of these factors have the same base. So my answer would be 3 to the 4 plus 2 power, which simplifies to be 3 to the sixth power. On the next problem, we have x times x to the second. Now remember, if there is no exponent next to a term, then it has this invisible 1. So let me draw an invisible 1 on top. So that's going to be x to the first power, okay? So if it helps you, you can go ahead and put that invisible 1 next to the x. So since both of them have the same base, they're both x, we have x to the 1 plus 2, which is x to the third power. The next is 7 to the second power times 7 to the eighth power. They both have the same base of 7, so I'm just going to add the exponents. 7 to the 2 plus 8th power, or 7 to the 10th power. The final one is b to the 10th power times b to the 5th power. They both have the same base, so I just need to add my exponents together and I get b to the 15th power. Here's an example of making a mistake. Let's say we make a mistake and we end up multiplying the bases, when in reality we should have only just added the exponents. So if I take 4 to the fourth power times 4 to the second power, and I make a mistake and I multiply these two bases together and get 16, and then I add my two exponents together of 4 plus 2 and I get 6. Well, what I really have is 16 to the sixth power as my answer. But if we look at this again in the correct way, we can see that 4 to the fourth power times 4 to the second power in expanded form equals 4 times 4 times 4 times 4 times 4 times 4, which is 4 to the sixth power. So these two answers are not equal. 16 to the sixth power is incorrect because we multiplied the bases. So you can see it's very important. Do not multiply the bases. Just take the base and add the exponent. What happens if we have a coefficient in front of the variable? Well, I want to review that a coefficient is a number that stands next to the variable, and that number is multiplied times the variable. So for example, 5x equals 5 times x. Negative 3 a equals negative 3 times a. In this example, the coefficient is negative 3. In this example, the coefficient is 5. Let's try to multiply some exponents that have coefficients. Here we can see that we have a coefficient of 2 in the first term and 10 in the second term. So my rule says multiply the coefficients. So that means I'm going to have 2 times 10, which is 20. Then my rule for exponent multiplication says to add the exponents that have the same base. X to the 2 plus 7. So my answer would be 20x to the 9th power. What happens if we have a number or variable that doesn't have an exponent? How do we multiply those with other exponents? Okay, I referred to this earlier. If there's not an exponent associated with a number or variable, then it automatically has an exponent of 1. So 3 to the first power means 3. X to the first power means x. And then if I want to add my invisible exponent of 1, z to the first power equals z. So any item or term raised to the first power equals itself. You can feel free to add an invisible exponent to any term or variable that doesn't contain an exponent, just to help you make the right calculations when you multiply. X times x to the fourth. Let's go ahead and put our invisible exponent of the first power next to the x so we don't forget it when we multiply. So we have x to the 1 plus 4 power, or x to the 5th power. Let's try another example of exponent multiplication. In this example, we have a coefficient of 2, and then x to the third really has an invisible 1 as its coefficient. So when we multiply those together, we get 2 times 1, x to the 1 plus 3, 2x to the 4th power. And again, if it helps, we can always put this invisible 1 next to the x to remember that that 2x really is to the first power. So let's think about this invisible 1 as a coefficient. If there is no coefficient in front of your variable, then you can go ahead and put an invisible 1 in front of it. Okay? So the coefficient of x in this example would be 1. Let's summarize. Our rules of exponent multiplication are to add exponents that have the same base. I'm going to caution you, do not multiply the bases. Just add the exponents with the same base. This is a really important concept. If you don't see an exponent, know that that term has an exponent equal to 1, and feel free to write an invisible 1. So if we see the term x with nothing next to it, we can put an invisible 1 here because that x does have a power of 1. If you don't see a coefficient in front of a variable, then the coefficient is always 1. So in this example, going back to this example of x to the first power, we could also put an invisible coefficient in front of the x, which would be 1. So I want to leave you with one thought. When in doubt, use the expanded form to multiply exponents. So if you forget what the rule is for exponent multiplication, you will always get the right answer if you use the expanded form, and we did that at the beginning of the video. Using expanded form can be a little bit tedious, but it's a great way to check your work or to use this process if you forgot the rules of exponent multiplication. Thanks for watching.